Hi, today's lesson is going to be about radiometric dating or carbon dating. So the learning objective of today is that students will be able to describe carbon dating. So if you remember in the last videos, we've talked about how can we determine the relative age of a certain rock layer, where we actually compared that rock layer to other layers, and we could have only tell whether it's younger or older comparing to other layers. However, in today's lesson, we're going to talk about how can we actually determine the absolute age of a certain rock or a certain organism. So as a starter question, think about this question before we actually start the session. How can we measure the exact age of a rock? And when I say exact, I'm just saying the absolute age. Exactly. Have a minute to think about that before we move on. So you might be wondering now, where can we actually find carbon element in this periodic table, which is filled with so many other different elements? So I'm just going to give you a quick hint. So you're going to find carbon element in group 14, period 2, or what we call it also group 4a, period 2. Have a think and look for it. Yes, here we go. This is carbon with two numbers. One, the smaller number on the top, and the bigger number on the bottom. And in fact, I have two isotopes of carbon. We're just gonna go into isotopes in few minutes. So I have carbon 12 and carbon 14. 12 and 14 determines the mass number. So what is actually radiometric dating? So radiometric dating is a method used to obtain the exact or the absolute age of a fossil or a rock. So I'm actually using, in particular, I'm using carbon 14 to determine the absolute age of a certain rock. Okay? So I said now, isotopes. But what are exactly isotopes? Have a minute to think about what do you think isotopes are? Okay, so isotopes, so I have carbon 12 and carbon 14. They are isotopes for carbon. So isotopes are atoms of the same element that contains different number of neutrons. Okay, so again, isotopes are atoms of the same element that contains a different number of neutrons. I'm underlining now same element, and then they have to have different number of neutrons. So for instance, here I have carbon 12 and carbon 14 are isotopes for carbon because they are the same. I have carbon and carbon, but the number of neutrons, which are determined by the mass number on the bottom, 12 and 14, are different. Okay, but they are the same element. They have to be the same element. So now the question that instantly pops into my mind is, how does carbon get into our bodies? So carbon is everywhere. It manages to find its way into just about everything around us. So in fact, all living things are made up of carbon compounds. So carbon mixed with other elements. So we find it in the food we eat, we find it in the air around us, in the atmosphere, everywhere. So in the atmosphere, we have carbon in the form of carbon dioxide. So I have carbon 14 and carbon 12, and then they go into the plant because plants use carbon to photosynthesize. They need it in the form of carbon dioxide. Then when an organism takes it in, so it goes into its body when the animal eats the plant, so it goes also carbon 12 and carbon 14 goes to the animal itself. But the question is, what happens to carbon when the organism die? That's the actual question that you need to be thinking about. What happens to the carbon inside the organism when it dies? So now we all agree that carbon is all around us and it's everywhere. So carbon transfers from the atmosphere in the form of carbon dioxide to autotrophs or plants, and then from autotrophs to plants it goes to the consumer, which is like the living organism in that case. So usually carbon is found in the form of carbon 12 and carbon 14. So the carbon dioxide, the carbon inside it could be 12 or 14. Okay? The ratio between carbon 12 and carbon 14 is constant in the atmosphere. So I have the first case in here. So I have the living organism. So the ratio of carbon 12 to carbon 14 in this living organism, or generally in living organisms, are going to be similar to the ratio of carbon 12 and carbon 14 in the atmosphere. So again, the ratio of carbon 12 to carbon 14 is very similar to that of the atmosphere because it keeps on taking carbon 12 and 14. However, in dead organisms, the ratio of carbon 12 and carbon 14 might change slightly, and it will change slightly because the organism is no longer consuming carbon, because it's no longer eating any of the autotrophs. So the ratio is going to change. How? That's the question that we need to be thinking about. So carbon 14, specifically I'm saying carbon 14 is going to decay. What does it mean when I say it's going to decay? It means it's going to break down. So when the organism die, the carbon 14 is going to change because it's going to decay. So after a while, after years passing by, the carbon 14 ratio, it's no longer going to be similar. So let's say it in simpler words. So if an organism just died, so it just died like, let's say 1 day ago, the amount of carbon 14 is not going to go down as much. So it's going to be similar to the atmosphere because the organism has just died. However, if it's been a very long while since that living organism died, the amount of carbon 14 is going to be less than the carbon 12 or than the start, let's say. So the amount of carbon 14, it's no longer going to be the same. It's going to be less because the organism, again, it's not consuming carbon. Again, because more time has passed for the decay. So it took time, so it kept on decaying over and over and breaking down. So we use carbon dating to determine, as we said, the absolute age of a rock or an organism or any sample at all. So again, we use it to determine the absolute age and the exact age. But the question is, why do we rely on carbon 14 to determine the exact age and not carbon 12? Why do you think so? I'm sure by now you got the right answer. The answer is simply because carbon 14 is not stable. Right? So carbon 14 is unstable. That's why it keeps on breaking down, or the scientific word is decay. So carbon 14 is unstable and it decays, unlike carbon 12. So it decays to become carbon 12. And in fact, actually carbon 14, believe it or not, it's coming from nitrogen 14. So here in the atmosphere around us, you find that I have carbon in the form of carbon dioxide. It could be carbon 12 or it could be carbon 14. Okay, so it's a mix of the two carbons because they are isotopes for each other. They are isotopes, in fact, for carbon itself. So now, since we all are on the same page, it's time for checking your understanding. So question 1. Which of the following is used to tell the age of living things? Absolute age or the exact age for living things? As we discussed in the video, the answer is going to be carbon 14. We use carbon 14 to determine the absolute age of living things. Question 2. Which of the following items could you use carbon dating to determine the age of? Think about it. So the answer is we use carbon 14 to determine the age of a rock sample or just a rock. Question 3. Where does carbon 14 come from? The answer is nitrogen 14. I mentioned it briefly in the video. So nitrogen 14 breaks down to become carbon 14. So if you understood this video, that's great. If you almost got it, please rewatch the video. If you need some help, please write your questions in the comments and I'd love to help you. Alright, I hope this helps. Bye.